Hey guys, welcome back. We are here with Mesut Durukal, and he's going to continue the topic of artificial intelligence. Mesut is a automation lead at Siemens at the moment, and he has a 7 years experience in defense industry, working in multi-location projects, serving as the manager of verification and validation activities. So if you have some questions about these topics or something else, please keep it up in the chat. Stay alive, and Mesut, I think stage is yours. You have a lot to tell us, and I hope we'll answer some questions after your talk. Welcome.
Yeah, thanks so much. And hello, everyone. Welcome. I'm very happy to be in this amazing conference. And in this session, we are going to talk about some practical applications and adaptations of artificial intelligence and machine learning algorithms in software testing stages. But before diving into the subject, let me briefly introduce myself. My name is Mesut, and I'm from Turkey. I'm a QA engineer with more than 12 years experience, and currently I'm working for Siemens Istanbul office. But this is my last day in Siemens, and from next week I will move to another country and another company, and I will start living and working in Japan, Tokyo. And here you can find some contact information for me, so please do not hesitate to reach out to me or just feel free to contact to me. And this is the brief agenda for this talk. We will start with a quick reminder, and we will quickly remember how the learning algorithms work and what is the underlying principles for those. And then we will go over one by one the applications and adaptations of machine learning algorithms in different stages of software testing, starting from the analysis of the requirements, test case design, implementation, execution, and maintenance stages. We will see all of them, what we can do with the help of machine learning in our activities. And finally, at the end, I will share a case study in which I try to guess or estimate the several levels of bugs according to their descriptions or summaries. So let's start with the first part, the introduction section, in which we will quickly remember the underlying philosophy or the mentality of the machine learning principles and the learning terminology. First of all, let's discuss why are we talking about this? I mean, why are we searching for some adaptations of machine learning in software testing? What is the relevance? Because nowadays most of the researchers or scientists are working heavily on machine learning and artificial intelligence. But as we, as software testers, should we really be involved in this hot topic as well? I think, yeah, because we are searching for some improvements in our software testing activities, and we are searching for some adaptations from different platforms because we have some challenges. Today, we have a great rivalry in software market, and everyone is trying to be the first in the market. Everyone is in a rush. They're adapting latest technologies into the products, and they're integrating their products and tools and platforms to different ones. So we have a very dense structure and complex and complicated context to be verified, and in a very limited time. Personally, sometimes I remember I have only a 1 hour testing window before going production environment. So it is very stress, and sometimes you feel under pressure. And we are working in agile environments. We are encountering lots of frequent updates and changes. Sometimes start working on verification activities on the features of the product, and then I learn that the features are already updated or changed by the developers or by the owners of the product. So we have to adapt very quick and fast and consistent solutions and new ways to complete our tasks. And it is challenging, it is tricky because sometimes we feel we have to need or we need some support or help from some other solutions. And this is why we can check if machine learning algorithms is a good opportunity to use. And now let's discuss this point. Can they really help us to overcome our challenges? Machines are built or designed by the human beings, so we know that they have already some limited capacity in some manners. But in some other aspects, they have definitely some advantages and powerful skills. For example, they do not forget, right? If you put an information into a machine, then it is always there unless we delete it. They do not forget and they do not get tired. I mean, at the end of a long working day, maybe we are very tired and we already want to go home because we work much. And at those moments, it's very likely to miss some bugs and vulnerabilities because our concentration and motivation went down. And at the end of the long working day, we are already tired. But for the machines, it's not the case. They are almost working at the same level, in the same performance in every condition, or almost in every condition. So they do not get tired, they do not forget. And for the resources, it's not easy to add some additional resources to our project, right? Because if you add another colleague in the team, then he or she needs some additional adaptation time. But for the virtual machines, we can immediately create another one, another resource, and add to our resource pool. It is not that difficult. So we can utilize these benefits and advantages of the machines and the machine learning algorithms, and we can observe that they started to overperform human beings. I mean, this scene is from the Go match between the champion of the game, or one of the ex-champions of the game, and the machine. And the result was really surprising for the champion because he did not expect this. And maybe frustrating, maybe disappointing, but because Go is one of the most complex games. It has lots of patterns, lots of alternatives, and the machine can think about all the patterns and all the alternatives in a very complex way. So it has a very high capacity to check all the alternatives and all the possible routes, possible patterns. And we already see that it is being used in lots of different platforms and applications and tools. This table just summarized the tools in which machine learning techniques are used in software testing purposes. But apart from this, in our daily life, we can observe in lots of points the usage of ML and AI approaches. For example, when I start replying to one of my emails, I started with hi, with a greeting, and then I see that it is automatically completed by the algorithm. It is after the hi word, it is completed by the name of the sender. Because yeah, bingo, it works. Because how does it know that? Because from the past experiences, past patterns, most of the users use this in this way. After after the greeting, they call the name of the sender and then continue their work. So it really makes life easier for us because I don't have to bother myself to manually write the rest of the word, the rest of the sentence. Or sometimes my smartphone warns me to immediately leave to reach to the office because otherwise I would be late. And how does it know that? Because it knows, it observes my patterns, my daily routines. At what time I'm leaving home, at what time I'm reaching to the office, and the traffic level of the city where I live, lots of things. It observes my routines, it learns, and it predicts my future actions. It estimates the future actions and reactions. So it works in a very similar way in software testing activities as well. And I remember sometimes some men were complaining about their wives. The machine is knowing me better than my wife because it really can observe your data, all your actions, movements, and then it can learn all your patterns. It is a very easy task for the machines and the algorithms. And at this moment, let's discuss the meaning of learning. What does learning mean? Because it is something different than memorizing something, or it is something different than being explicitly programmed. And then what is learning? Actually, it is not a very niche area, and it is not a very new study because Alan Turing was asking this question in 1980s. He had an article in 1980, and he had the bravery to ask this question: if whether the machines can think or not. So, thinking and learning something is, as I told in the beginning, is not memorizing something. Because if we face some new samples, which we are seeing for the first time, then we can still make some estimations or predictions. For example, when you see the image on the bottom of the slide, you can predict it's a chair, right? It is not a traditional one. It is not an ordinary chair with four legs. But still, you can predict what its functionality is because we know how it works. We know the working way of a chair and why it stands for. We can sit on, and we know what a chair is. It is the first time maybe for you to see this one, but you can still know or you can still predict what it is. And for a baby, when he touches a hot object, for the next one, even if it is not the same one, it can guess if it is over an oven or something else. Then he can predict the consequences from his past experiences and past observations. So we will make use of this learning algorithm in our activities as well, and we will go over them, go over each of them one by one. But at this point, I can remind you that it works very similarly with the biological learning principles. I mean, when we see a cat coming from across us, and the first thing that we do to recognize what is coming is first the outermost frame, to process the outermost frame, and by evaluating the shape or the size, we can guess what it can be. For example, it can't be a lion or a tiger because it is not that big. And then the next features, and finally we finalize our decision. And it is very looking like a deep learning algorithm because it is a processing which is performed gradually, and at the end, according to the features that we investigated, we make our decision, we make our recognition. And in our problems, the most critical part is to collect some data. Because if we do not have sufficient data, we cannot teach to the machines, right? We cannot teach our system to the machine or our model to the machine. And when we feed our and provide our data and information to the machine or to the algorithm, then it learns the patterns, the underlying methodologies, and constructs the model. And according to this model, the further samples are or can be processed or put into the algorithms. And then according to the predictions, we can evaluate the performance of the model or performance of the algorithm. Then if we are not satisfied with the results, then we can update our model. But the most critical part is to feed the related data to our model and our algorithm, and then make it learn. And it is very, again, let me give an example from our daily life. As a software tester, if you come to me to test your system, my response would be, okay, I can test your system, but first of all, teach me how it works. Because I should know what kind of buttons there are on the pages, what kind of APIs you have in your endpoints, in your services, and how I can call them, and what kind of responses I should get. I should know all of these because otherwise I cannot test. Okay, I can do something, but and I can have some responses, but if I do not know the expected results, the expected responses, I cannot evaluate if the actual responses are in the correct way or not. If the system is working properly, I cannot evaluate this without the expected result because first of all, I should learn what are these reactions to my actions, and then I can start my work. So for a system which will be tested with artificial intelligence assistance, we should do the same. First of all, the machine can learn all the endpoints, all the APIs, UIs, everything about the system. For example, if there are lots of APIs in the system, then the queries can be observed and some patterns can be learned. For example, we can learn that after our unsuccessful queries, we can get maybe 400 response, right? For example, if our query is not in a good format, if it is in a bad format, then we can get 400 response. Or if it is unauthenticated one, then maybe we will get 403 or 404. After observing all these, if we generate another test case automatically in the next round, and if we inject an unauthenticated query, then we can guess we should have a 403 or 404 response, right? Or not 404, 403 response, because we already learned it in our past experiences. And for the UI case, it is working in the same way. We can navigate through all the pages in the system, and we can see how it works. When we click a button, to which page we are navigating to, or when we fill some forms, how it works, we can observe everything and we can learn what we do and what we should do. And we can develop, of course, lots of different solutions according to our problems. For example, if our problem is a supervised learning problem, then we can develop some related algorithms. Otherwise, if we have to solve an unsupervised learning problem, then we can develop some according solutions as well. So after this introduction section, let's now proceed with the applications that we can do with a collaboration between the human beings and the machines. I want to do this in a systematical manner. I will go through each of them one by one. So this is an ordinary software testing lifecycle, starting from the analysis of the requirements. And this is naturally what we do in a software test automation project, right, or a software testing project. Firstly, we analyze the requirements. Then we generate some test scenarios to cover them. And then if we are responsible for the automation, we implement test code, we inject to our CI/CD pipelines, we execute them, and finally collect the results over them. And if there are any vulnerabilities or any unstable situation, then we maintain all these situations and we fix them. So at the end, we continue with the maintenance stage. And at this point, the critical point is there is an input-output relationship between each two consecutive ones. I mean, when we analyze the requirements, then we construct our test cases and we build a traceability between these two, right? There's a mapping between these two. Because firstly, we analyze and understand the requirements, what kind of features we have, and then we generate some cases to cover them. So somehow we relate these two. So we will utilize this relationship, and we can do that in each two consecutive stage. And first of all, let's start with the test case generation stage. How we can do with the help of machines or with the help of artificial intelligence. Again, firstly, what we have to do is to construct a model to learn how the system works, and then predict the future steps or estimate the future steps. So let's go over some examples. I believe it will be more clear in this way. This is an API what we see on the screen, the API of a library, and you can query some books, which is in the library. So after my query, after I perform my query, I get a response. And in the response, I can see that there are some different fields. For example, there are different book entities, and in each entity, I can see the ISBN number of the book, the price, the publisher of the book, lots of different information. And apart from that, I can see another thing, which is the data type required to express these fields. I mean, the ISBN number of the book is expressed with a string value, for example. And now I can guess that if I will send a query, for example, a post query in my next execution, then I should inject some values into these fields, right? And in the required data type. For example, if I inject a string value in the year field, then maybe it will be in the bad format because normally I need a double value to express the year information. Otherwise, if I inject an integer value to ISBN number, then it will be again in the bad format because normally I should put an string value. So see, we can already generate automatically or heuristically some test case generation activities. We can automatically generate them in the positive scenarios terms or in the negative terms. We can both do that by injecting some different data and some different data types. And for the UI, again, we can visually recognize what kind of buttons and what kind of icons there are on the pages. For example, again, from our daily life, when I go to an online shopping site, I can order something online, right? And this is mostly what we will do in the COVID days. We can go to some online shopping sites and we can order something. And even if it is the first time for me to use a site, I can still use it. I can still order something. And how do I do that? Normally, no one taught me how the site works, but I am able to do that because I used not that one specifically, but maybe some other sites in my previous experiences. and I know what kind of icons are standing for. For example, when I see a basket image on the page, I can imagine that it works for an online shopping cart. I can guess the functionality. So it is from my past learnings. I already learned that what can the functionality be of each image or each icon, and then I can already generate an automatically generate a test flow, right? For example, I can add lots of items to the cart, and at the end I can go to the online cart page and check if the items are there or not. So in this way, visually, I can generate some test flows and test scenarios as well. And after we generate all the test cases, what we do next is to implement them, to integrate the code into our pipelines. So the first way of doing this is if we are responsible to test a class, for example, we can detect all the callable methods in the class with the related parameters, and then we can call them with different usages. For example, we can inject again some different parameters to call the methods and call in different ways. And we have the documentation already in the class. Then it is much more easier because from the documentation we can understand what the response should be or how the usages are in the system. So in this way we can detect all the callable methods and call them and see if they work or not. But another way of implementing code is to understand the relationship between the input and output. For example, we sometimes we should develop some code in which some particular input should be converted to another series, another output values. So, for example, on this example on this slide, we have an input-output pair, and for us, for human beings, it is not very straightforward to understand what is the relationship between those two. But for a machine, it can be understood in seconds or milliseconds, maybe. Every value is multiplied with 4, and the positive values are filtered out. And finally, they are all sorted from starting from the biggest to the lowest. So we already know the needed operations to reach to the output from the input. And after detecting these operations, we can immediately inject the related code to perform those operations, right? It is the easy part, but the challenging part is to observe the related operations and the relationship between those two. And finally, one other alternative to make life easier for us is not to develop the code from scratch, but to autocomplete to use autocomplete methods. For example, when I start typing something, let's see the example on the slide. When I start with you, then most probably I will continue to complete the unsigned, right? Because in the previous lines, that is what I did. So it is not very difficult to predict what I will write. When I start with you, it can be completed with to reach to unsigned words. So it will be much more easier in this way when I get some help from these machine learning algorithms because they suggest the most likely pattern to me, and they suggest some patterns that will I can use in my future steps, in my future actions. And for the UI automation side, again, let's go over one example because this is, I believe, most of the software testers are aware of this. I mean, we are mostly miserable from this UI automation, right? Because it is not stable all the time. Sometimes we try to locate some elements on the page, and then because we can locate them by their IDs or XPaths or CSS paths and lots of different locators. But maybe next day my test is broken. And why? Because the ID of the element is changed already. So then how can I reach to this stability? Each day should I maintain and should I update the ID of the elements? Obviously, it should not be the case. And what can I do? Instead of using these traditional locators and traditional selectors, I can recognize all the items and all the buttons on the page by visual recognition algorithms, right? And this is a code, example code, taken from test.ai repository. They have an open repository, and you can go and check how it works. So this is why I put the example on the slide. This is from an open repo, and they just pull all the images from the page and try to find the one you are looking for, you are searching for. So see, instead of using the IDs or some other locators, we just recognize it visually. And in this way, we can reduce the fragility or the instability in our test executions. And after we implement all our test cases, what we do next is to execute them. And during all the executions, we can collect some data, right? For example, we can collect the execution duration in each hour execution. For example, let's say in 10 executions, my average duration was 15 seconds, let's say. And in the 11th one, if it is not around 50 seconds or 15 seconds, or but it is 2 minutes, then I can guess that there is something wrong here, right? Because it is an anomaly. Normally, I had a trend. I made my trend analysis, and I was expecting that duration of execution should be around 15 seconds or 20 seconds. But now it is 2 minutes. So I can go and check if there is something wrong, if the configuration is wrong or what. I can check what went there during the execution. So instead of going one by one to analyze or understand the results or details of the results, the machine can automatically warn me. In this execution, I found an anomaly, so please go and check it. And apart from the execution duration, we can similarly collect lots of data. For example, we can watch the number of calls per each endpoint. For example, when we perform a get query from an endpoint, maybe in average, we were performing the query maybe 3 or 4 times in each execution. But if we understand in a specific execution, we send the query 10 times, 20 times, then again, we found an anomaly. So maybe at that time, the endpoint was not responding. So that's why we frequently tried to poll for the result. That's why we tried to send the result 10 times, 20 times instead of 3 or 4. In this way, we can detect all the anomalies, all the unexpected situations automatically, and we can cure them much more in a faster way. And the last stage that we can use machine learning stages or approaches in our stages is the maintenance stage. And in terms of maintenance, what we do is to refactor our code, to review our code in terms of the code quality, or managing of the bugs, right? For example, let's start with the code refactoring process. Normally, how do we perform our code reviews? If we are performing a peer review, then after I develop my code, I will send it to another one in the team, and he or she will review my code. And if she detects any vulnerabilities or weaknesses in my code, then she sends it back to me, and I will improve them and send again. So sometimes it is a waste of time. It requires this operation requires lots of time and effort and cost. It is not easy. So we can do that automatically over machine learning algorithms. And how can we do that? If we somehow can teach machines how we review the code, then it can do it in my name. Okay, then how can I teach them? Because normally I have a checklist, right, to do my code review process. There are some steps that I'm checking. I'm checking if I have some magical numbers inside or any security threats inside, lots of different checks. So if I somehow teach these checks to the machine, then we will be able to do that over them. So for example, let's think being or having some magical numbers in the code is not a best practice. It is an anti-pattern. Then in the next run, if it detects some magical numbers in the code, then it will warn us. You told me that this is an anti-pattern, this is not the best practice, and now I find some. So please go and check it. Please go and fix it. So in this way, we will we can have code reviews in a very faster and consistent way. And our code can be structured by dividing into smaller pieces, and then the code review process can be performed over each of them. And apart from code review processes, we can embrace some self-healing approaches as well. For example, we already discussed about the fragility of the test cases. From different reasons, our test case can be broken. And if we somehow understand the root cause of this breakage, then we can apply the needed action items as well. For example, if we were checking for some image on the page when we are automating the front end, then if the image is changed, then we can immediately apply the new image on our test code, right? So these kind of changes can be detected by the algorithms, and it can suggest the possible action items to fix our code. If the ID or the structure of the element is changed, then it can suggest me to update my code as well, because my code is now not up to date. Because the element I'm trying to search is updated, and my code is still trying to find the old one. So the algorithm can suggest me to update my code as well, and in this way I can immediately do the related tasks. And finally, infinite testing is not possible, right? So sometimes we need some prioritization. We cannot execute all of them in limited time. So what we can do is to maybe execute the most prior ones. And how can I select the most prior ones? Of course, I can do some prioritization, and I can group them, I can cluster them by the help of algorithms. For example, if my priority is to defect some bugs, if this is my priority, then I can make some clusters according to likelihood of finding bugs. I mean, in some cases, in the past executions, one test case is the most likely one to find some bugs. Of course, that would be the most prior one for me. So after analyzing all the past executions and likelihoods to find a bug, then I can order them by their prior probabilities or likelihoods to find the bug, and already make my prioritization as well. And to manage the bugs, and in the scope, I will share a case study and some results to you. It will be more clear to see over a practical example. But what we can do is to make a triage and to estimate the correct assignment, or again making some clusters on the bug. Because if we assign a bug to a wrong person in the team, then what we will do? He or she will reject this bug, because she will tell us that, okay, you assigned this bug to me, but I'm not the correct one. Please assign it to another one. So again, see, it is a waste of time. We will lose days, and it is very critical to work efficiently. So at the first time, it is very important to assign to the correct one, or assign in the correct severity level. Because normally, if it was a high severity bug, and if I assign it to a low severity, then maybe it will not be prioritized. Maybe it will be postponed to the next sprint. So it is, for me, it is very important to assign the severity level as well correctly, properly, because otherwise it will be an inefficiency in my life cycle and the procedures. So now in the last part, let me share my case studies information and the results. And in this project, I had some bugs reported by the customers and the development team members as well. And totally we have around 1,000 bugs collected and exported from our issue track system. And there are 6 different severity levels in this project. There are 6 different levels, but level 5 and 6 are not regarded as the real bugs, but change requests. So we can think that there are actually 4 actual levels. And one of them is not present in this project, because those are opened in the human life issues. I mean, if you have a hardware and if there's a current leakage, and it can harm to human body or life, then it will be a severity 1. And in this project, actually, we don't have any severity 1. So we have 2, 3, and 4. We have 3 different levels. And by reading the description of the bug, can I imagine on which level it should be? It should be 2, 3, or 4. Which one? This is the challenge that I have to achieve, and this is the thing that I want to do with the help of machine learning algorithms. So let's see how the results are looking like. So this is the view of the extracted features. We make use of some TF-IDF methods since we use NLP techniques, natural language processing, because our samples are now written in some language, right? Because we are working with bugs. It is not image, it is not sound, it is not video, nothing else, but just text. So we work with NLP techniques, and after we extract the features, we do the classification. And this is the distribution of all samples in different classes. We have class 2, 3, 4 samples, and after this distribution, this is the first view of the confusion matrix. And I have overall 73% accuracy. So it can be acceptable, but it can be still improved, right? And what I detected about an improvement point is the distribution was not very balanced one. There was a bias in 72, if you remember. Most of the samples were in class 2. So what I did next is combine 3 and 4 together. And now it is much more balanced, as you see. There is no bias anymore. And does it make sense? Does it make sense to combine 3 and 4 together? Why do I do that? Because in my project, 72 levels are regarded as the release blocker ones. So determining if a bug is a release blocker or not is a prominent issue and prominent challenge for me. So now I will try to classify if a bug is 2 or not. And in this situation, the result is, as I see on the confusion matrix, is much more balanced. And the overall accuracy is 82%, and it is much more acceptable, I think, I believe. And when I argue about the results, it is a really challenging and difficult task, right? Because eventually, who is right? Machine is suggesting some several levels, and normally a human being already assigned a level. But maybe I'm wrong. Who knows? Because I do not observe all the other samples created in the project. So maybe still machine is suggesting the correct one, the consistent one, and there are still, of course, some more improvement points to increase the accuracy. And apart from classification, of course, we can cluster the bugs to group them, to collect the similar ones together. And in this way, we can much more work efficiently on the bugs as well. And this is the visualization of the clusters taken from our algorithm. And I'm closing to the end of my talk. So let me quickly summarize what we have discussed in the session. We went over lots of applications and adaptations of machine learning in different software testing stages, right? Starting from the first stage, the test case definition, then implementation, and execution, maintenance, lots of things. Because sometimes we wonder about what's the relationship between machine learning and software testing. But there are lots of opportunities that we can utilize. And in this one, we went over lots of alternatives. And I shared some commercial platforms and tools as well, and some scientific researches. So you can go and check how they work. And last but not least, it is possible to build a collaboration between us and the machine learning algorithms. So I hope you enjoyed the talk and get some insights. And if we have any questions right now, I will be more than happy to answer them. Thank you so much.
Okay, thank you very much. And we indeed have a question from early on. Yevgenius is asking, let's see, what do you think about the QA engineer profession future? Will it still be in demand or dying off? Maybe QA role will disappear and be incorporated into developer's role. What is your own personal opinion on that?
Yeah, my personal opinion is, of course, the software testing will not disappear, but maybe change the shape. I mean, let's remember at the old times we were performing most of our activities manually, and now most of us are working in test automation projects. And in the old days we were performing some waterfall approaches, but now we are performing and following agile approaches. So they can change, and in the future, okay, it can change, but of course I cannot imagine any life cycle without QA activities. So it will not emerge in development activities, I think, and I believe. But of course, we require some other skills as well. For example, nowadays it is a luxury to reject to check the code. We should have some development skills as well as a QA guy. And in the future, maybe we should have some machine learning skills as well too. So this is what I believe. Maybe we will do that in another way, but still, of course, we will need the QA activities in our projects.
Okay, thank you very much. I think Yevgenius is probably happy with the answer. And that's about it. That's our time. And do you have any last words to say to your audience before we say bye?
No, thanks so much, and enjoy the rest of the conference.